Um, this presentation is about the new generation for UCP protocols, which is supposed to solve several issues that we have today. And so today, the logic for selection and protocol thresholds is kind of scattered in multiple places. We have the huge function to initialize endpoint configuration, and we have different logics in different protocols, and it's all very ununified, scattered in different places. Once a while, we see conflicts in thresholds or things are not working as expected. In addition, we don't support selecting different protocols based on memory type and memory locality, which is what we need in order to really have a good out-of-box support for GPUs. And we have actually quite a lot of checks if the message is not inline. We check the message size several times. We check different conditions, um, and it's not very efficient. Also, several protocols have to initialize many things during runtime, like rendezvous, has to check several bitmaps, resolve remote keys, which is also not a very good thing to do. And actually, much of the logic in there we can do upfront. And in addition, we saw cases where we need to change the endpoint configuration during runtime. For example, when we initialize connections, we might want to start with a small subset of transports and then progress and change to the real set of transports if we exchange additional information. And this is not really possible today because the request would basically fail. And when we detect some error on the connection, we don't have a good way for that we can cancel or abort every protocol. We could result in memory leaks or things are not really completed or not really released. We actually have to take care of each protocol in a different way. And we don't have like a common API or callback which can handle or encapsulate the behavior of every protocol. In addition, some of the code that we're doing during the protocol progress part, like multi-rail or switching from one lane to another, is not really reusable. It's very coupled today with active messages. It's not generic. So what we're going for is we want to separate the protocol definition from the protocol selection engine. And the protocol cutoff and thresholds would be generated in some generic way. So a protocol would just advertise its estimated performance on different message sizes and memory types. And the common logic would be able to combine all of them together and generate the optimal thresholds. So we don't have to assume, for example, that first we start with short messages, then we go to be copied, then z copied. This is not necessarily the case for all memory types. And the generic logic would be able to handle all of that. So the first thing that we can do is we create a protocol selection key, which is based on properties of the current operation. So it's the actual operation code like tag send or active message send and so on, the data type, the memory type, memory locality, and maybe some additional flags, like whether we want a fast completion or we only care about the latency to the remote side. So all of these can be combined together into a hash table. So instead of doing multiple checks, we can do everything at once. So maybe a hash lookup could be a bit slower than a single branch, but it's definitely faster than multiple branches. And we have this hash table per every endpoint for operations which are local, like sending stuff. And we have it for on the remote key for remote access operations, including the rendezvous protocol, which actually has a remote memory access component to it. And if we have similar endpoints or remote keys, they can share the same table. For example, endpoints which are all intranode are working the same way probably, or endpoints which are all internode would also work the same way. Same goes for remote keys which map the same subset of memory domains. So we don't end up with a large number of such tables. And also we initialize all the hash table entries at first use. So it doesn't make sense like initialize all possible combinations of operations and memory types if the application wouldn't really need it. It's probably good enough to do everything the first time because typically application would use only like relatively small subset of such combinations. So this is like the whole data flow diagram. So we start with API calls, which could be either send operations or a remote memory access. The parameters of this operation can be used to construct a selection key, which is called UCP Proto Select Param T in the code. And in the first use, we would initialize the protocol and generate performance numbers and calculate thresholds according to the protocol definition, which is a static structure defined by UCP Proto T. As a result of the threshold calculation, we have such a hash table where, for example, for every kind of buffer, we have a list of thresholds. For example, we have for contiguous hosts, we might want to use a eager and zcopy rendezvous. And for GPUs which are far from the current NIC, we might want to use a eager and rendezvous pipeline. So after we have this hash table, we'll look it up using the select param, and then we get a list of thresholds, which is called in the code threshold LMT, an array of those. And we have a list that, let's say, for example, that up to 240 bytes we use short, up to 1K we use bcopy, and so on. And then we look up the message size in that array, and as a result, we get the protocol. But actually, we don't only get the protocol, we also get some private configuration of that protocol, which means which lanes it should use, which memory domains we should register, and basically everything that we are able to calculate up front. Especially in rendezvous protocol, many things that we do today in the data path can be moved to initialization path. And after we get that configuration, we can save it in the request structure in a new field. And then we can go ahead and progress the request according to the progress function.
Yossi, one quick question. So today we have an issue in moving GPU buffers between nodes when and between let's say we are talking about transferring a message from between two GPUs which are NVLink connected. One of the drawbacks today is that we'll go ahead and register that with IB, even though we can just map the memory using CUDA IPC and transfer. With this change, do you think we'll no longer do that because we can potentially configure the transfer to just use CUDA IPC?
Yes. So what would happen in this case? That the protocol that we select in here would be a GPU pipe, would be CUDA IPC. So can know upfront immediately after we selected the protocol that the current rendezvous operation is going to use CUDA IPC. So then the protocol also configures in the private data the map of memory domains which it should register. So we can look in this configuration and know that we only need to register on CUDA IPC.
Okay, that's good to know. So just historically, why was it the case that all memory domains were used for registration?
Because we didn't really have a good logic to distinguish that. It was like the simplest thing that we could do.
Okay. Thanks.
Yossi, but what happens if the memory is allocated through memory map call? Earlier, you still register with everything because you just don't know what will be used, right?
So if we select the protocols, we already know what the protocol is going to use. Actually, what happens is that the protocol would register the memory, and the first time its progress function would be called. It would be more efficient to do than having a separate callback for initialization. So once we start, for example, the CUDA IPC protocol, it would try and register the memory, but only according to what it really needs.
So you're saying that our UCP memory map call is not going to do any pinning, just memory allocation? And it will be pinning on first touch?
So regarding specifically for memory map, so you're asking if we can reuse the memory handle that was returned from memory map to in some send operations.
Well,
So
my
today,
question is, it's related to Akshay concerns that today we register with everything, right? So you potentially may register inside of protocol, and other registration may happen earlier when you allocate memory through memory map, and I think it's when we register everything today.
So yes, this actually doesn't help the case of memmap. It's kind of unrelated thing. Today, the only benefit here is if the UCT memory domain caches registrations, then UCP memmap actually inserts entries into that registration cache. So the protocol operation would still have to go to every memory domain that it needs, but then it would be relatively fast because it would be a hit in the cache. I think what maybe you're suggesting that we can pass memory handle to UCP send operations as an optional parameter, so the protocol could reuse the existing registration and not having to go and check everything.
Well, my question, even in memory map, again, going back to the same issues that we pin with every possible memory domain. We don't have to pin in theory when we allocate memory. We just can allocate the memory and pin it later when you actually use this memory first time. In this case, you will pin it with the right hardware.
So we can maybe add some flags to memmap where it should pin memory or actually register memory on on all memory domains, or maybe it shouldn't register at all and we just allocate memory for you. Because if you don't register, we can define that the operation RKeyPack on that memory handle is not supported. Another option we considered is that maybe we can pass endpoint handle to UCP memmap, and then the meaning would be that you are registering memory only for access by that endpoint, actually by the remote peer of that endpoint. And then we don't have to register everything.
But question if you, why to pass endpoint? Because whenever you change R keys, no, we don't know who will be changing it.
So today you don't know where you're going to send this R key to.
Yeah.
Maybe if you could somehow narrow down or like promise UCX API that only some of the peers are going to access that memory, then we can potentially register only a smaller subset.
Yeah, it's like typically you will share the key with multiple endpoints, so it's kind of will be very rare if it's just one endpoint.
Yeah.
Okay, so we don't really solve this map issue, but will be a bit better for other cases. And I'm curious, this hash table can grow pretty fast because of so many fine-grained parameters in this hash table, keys combination. Mm-hmm. So what will be the cost of looking up?
So we benchmark K-hash a while ago, and it's pretty scalable in terms of number of entries. Could add like 100,000 of entries, and it's still good enough. I mean, obviously you have a cache miss if you are using so many different kinds of combinations, but I think that according to the way that we construct this parameter, we wouldn't really have so many operations because, for example, you don't have so many applications which are using both tag API, let's say, and both RMA and atomics all at once. And all the different data types combinations all at once, it's also not very common, I would say. But however you try to turn it, it's still better than having multiple branches in the code.
Yossi, this is Manju. Hey, for something like random access benchmark, how do you see the impact? Because Archi would change, right, in this case all the time.
So it's not a problem as long as the Archi config itself is the same. We can, the question is not if Archi itself is the same. I mean, Archi can map obviously different pointers on different hosts, but the question is if the meaning of the Archi or the way that it affects protocol selection is the same or not. What we can say here is that each Archi has a configuration index, which is defined by the set of memory domains which are used on that Archi. And we expect that mostly the set of memory domains would be the same. Maybe you could have like 3 or 4 different types of Archis in your application, but it shouldn't be that many.
Okay. So
And
do you think
Yossi,
just
sorry, go on, Manju.
do you think that something like this, say that I have an application where I expect that a more uniform or I have an application where it makes sense for me to move this logic into, say, worker creation, right? I say that I give me the key, hash key that you use for selection, and I will use the same key. Rather, what I'm saying is, uh, can we make this explicit under responsibility of the user uh, for using the hash key efficiently?
do you mean that the API of UCX would also already receive the key which is created by the application explicitly?
Yeah. No, what I'm saying is if we make this explicit, right, the hash key, okay, I do this operation and I get a selection logic key. Is there a value? Because I can see that then the burden of a selection becomes burden of override, right, becomes on the user rather than the library.
So do you mean that to remove the hash lookup from UCX and do it in the application?
Do the selection in the library, but give the key back to the user, and user can use the keys efficiently, meaning that I know this logic, I will use this logic.
How would you use it, for example, for UCX operation?
Say that I have a workload where I feel like I want to move small messages in one lane, large messages in another lane, atomics in another lane. Now, what I want to do is I want to create a key for each of this logic, and if it is small, I will try to use all the small messages in that lane, right? For that, I need an explicit key.
I think you mean that there would be option for fine-grained selection of protocols?
Yes.
He wants to select Yossi. He wants to essentially UCT level of control through this key.
Yeah.
You can use the key to cherry pick transport, which is not a bad idea, by the way.
So I understand. I think this is not necessarily related directly to the key itself. It's more related to the protocol selection element in here, which is actually what the logic is doing. But yeah, I'll write this down.
The reason I mentioned that was right. Say that I have an application where I maintain different kind of traffic on a different set of queues, and I want for each queue to have a certain way to select it. Right. I already know this. I have a queue here, and I want to use this particular lane for this and this, and I already made this selection logic, and I will use it. Right. It's not necessarily a common case. It's a case where people really care about, say, tail latency, right? That might be useful.
Yossi, I had one more question. So I'm curious to know what the fallback mechanism is when you go in with the protocol selection element with a certain memory domain or in mind, but you're not able to register, for instance. What is the fallback there?
So that's a good point. It's still not exactly figured out. So actually we can have two ways to solve this issue. One way is that we can say that if a certain protocol tries to register memory and it cannot do it, it would then select a different protocol when it and then restart the send operation. I think that would be the simplest thing to do. Because actually we can do protocol selection from any place in the code. It doesn't have to be in the context of API call, for example. That's actually an advantage of the new logic, that all the protocol selection can be done anywhere and anytime. But then we kind of have additional overhead, because every time we start with one protocol, and since it cannot register, probably all the subsequent requests will also not be able to register their memories. So every time we have an overhead of 2 protocol selection instead of 1. Another option would be to pull up the memory registration to the common code and say that every protocol has a memory domain map that it has to register, and the common logic would try to register, and if it cannot, then it would try to select a protocol differently, or maybe one of the protocol selection parameters in the key would be whether the memory could be registered or not, or on which memory domains it could be registered. And the drawback here is that we have an additional branch in the common logic, even for protocols which do not require memory registration at all.
So is it not possible to maintain a priority list of preferred protocols or preferred domains to register against, and every time you fail, you decrement the priority such that the next time you still end up using what was successful last time?
So I think it would be equivalent to adding the memory registration yes or no value into the select parameter. So we could have one array for protocols which assuming that memory could be registered, and another array of protocols in case like the second priority if the memory could not be registered. It could be different altogether. Maybe it would be a completely different set of thresholds if we can't register memory.
Okay.
So personally, I'm more inclined to adding it to the common code, because eventually we could narrow it down to a single branch, and it would be more efficient in the case that we cannot register. So.
Okay. I'm mostly thinking concretely of one particular use case. In DGX systems, we know that some GPUs have NVLink connectivity, some don't. But when we see that we try to, map a peer memories, peer GPU's memory, if we fail, then the ideal thing to do is you have NICs close to both of these GPUs, so you should be using IBs. I think the same applies for SM as well. If you have, if you're trying to transfer between 2 host buffers, and for some reason you're not able to use CMA or KNM, then ideally you're moving to IB to move that.
Yeah, actually there are many more use cases. For example, we had users who wanted to have a limit on their registration cache. And let's say that we had a really hard, today we are thinking about adding soft limit, but we could also think about adding hard limit where registration could actually fail if we have too many registered regions in the cache already. And another potential thing is maybe we want to register memory, not at the first time we're starting to use it, but somehow count how many times a single region is being used. And only after a certain number of times or use count, we would actually go and register it. So it could provide out-of-box performance for cases like Spark where we could have buffers from all over the place. So we would better use pipeline protocols rather than using zero copy and pay the registration cost.
Makes sense. Good point.
Any more questions about the data flow?
Yes, just a short comment about Manju's idea how application can reuse the same key. Probably we can just don't release request after completion and have some API to replay the same operation, probably changing a few parameters which don't affect selection parameters key.
You mean like persistent request?
Yes, to have once allocated and request with selection key and have something like replay or restart the same request and probably change some parameters which don't affect this selection logic.
Mm-hmm. Well, the problem is at least one parameter which we probably have to change will definitely affect it, which is the buffer pointer, because we'd have to redetect memory type again. Yeah, we can cache it.
I think problems that Manju will have that he will, even if you return the key, he has no idea of what was selected in terms of transports. It's not visible.
Yeah, that's why I think you really want not the key, but the protocol select element, which is kind of a low-level structure.
Yeah, you want like list of tiers or something that we don't expose today. But if we expose, it will be possible.
I mean, it is basically right attributes on that key, right? You don't have to, you don't really have to specify per se, but you need to give some way of user to learn it, right? Maybe I just get a key, okay, then you can query the attributes, and the attributes can be whatever you use for your selection logic, right?
Yeah, it's almost like debugging functions that will let you dump your key value.
I don't think that, no, but it's more like, right, say you have an or an expert user or the user willing to understand this selection and make that right. So, and we can also mainly I think I want the key to be explicit rather than implicit. If a user doesn't want to use it, it's fine, right? It's very likely that most of the users would not use it, but there'll be a set of users who want to use it. Right?
So as a general comment for you as a, let's say, representative of a UCC library, if you see, for example, a case where the protocol that you really want to be selected is not the one that is actually selected, maybe there is some key property or some trait or some performance target or something like that, which is not being taken into consideration today. So I think in general, this is something which we can discuss and maybe add flag to the request to consider that or the other metric and then encode it into the protocol performance estimation, selection logic, and so on.
Actually, the question for me is triggered from OpenSHMEM rather than OpenSHMEM and PGAS rather than collectives per se. Why I think for OpenSHMEM it might be useful, or in PGAS in general, right, might be useful is because you want to reduce you say that we have a way to sort the traffic, right? I can somehow in my application, I can sort it, say that I have a small message, atomics, and large message, and medium message in a different, and I know what my lanes are, where my HCS are laid out, right? I want to better have a control on quality of service. And if I know this selection logic better, maybe I can use it better, right?
So is this something that you think is needed on the API level, or maybe it's enough that we have a really good configuration parameters which are able to select all the options if you're like an advanced user?
Sure, I think that's another way to solve it. So because you're presenting selection logic, I thought I'll bring up that question here.
Yeah, so actually this is something we didn't have before and didn't really have a good way to do it. We had thresholds which are very generic, like
Right.
medium to bcopy threshold and zcopy threshold and rendezvous, and that's it. I think that's a good point. We can have a config param to select protocols by name or select like the exact thresholds and so on.
I think that would be also, it's the same problem you can solve different way. I do agree.
It's actually quite different for us, like for UCX, because API which exposes this object is something which is kind of harder to do compared to configuration param.
Mm-hmm.
Okay. Any more questions? Okay. So the next slides are going into detail of different aspects of the data flow. So when we do a protocol, we write this kind of definition, the protocol name, several flags, and the most important functions are initialization function, which is responsible for returning the performance for every message range and return the unsupported error if it cannot run. For example, we cannot use a put protocol for tag messages and some debugging functions. And the second important function is the progress function, which takes a request, which is already initialized by the API call. For example, tag field is set and remote address is set when applicable and so on. And that function is responsible of doing all the sends on the UCT level. So it would do the UCT active message send, UCT put the copy and whatever in order to make progress and advance the state of the request. And after it's done, it's also responsible for calling the completion function. And also, sorry. All the requests are static structures, which are added to a global list by this macro. And whenever we have a new entry that we like to initialize in the hash table, the common logic goes over the entire list of registered protocols and tries to initialize all of them. So the cutoff logic between different protocols is also part of the common logic. Each performance is represented by a linear function, which represents the time as a function of message size, how long it would take to complete the request as a function of the size. And we can find the best protocol for every interval by walking on the intersections, because linear functions are easy to intersect in a generic way. So for this example, if we look at the tag API, we can have a short, eager, short, bcopy, and zcopy protocols, and also rendezvous. So in every interval, we find the lowest value, which is the best performance, lowest latency, and we select the protocol which goes with the lowest latency. It's for the progress function. So the API sets all the fields. It's also possible to reset fields and change them and select another protocol during runtime. And the protocol defines the progress function. And as part of this, we're also adding a new set of common inline functions for a multi-rail, resolving remote keys and fragmentation. So for example, we can reuse the multi-rail code between RMA operations and tagged operations, because today it's kind of a mess and it only supports active messages. And the protocol will call the completion. For the current implementation status, so today we have all the common infrastructure in place. We have the eager and the RMA protocol with basic GPU supports. Basic means that it can detect a memory type and make it work, but it's not necessarily optimal for all cases. Today it's off by default and it can enabled by that flag. So we would have some probably not very short period of time when both current protocols and new protocols would be implemented, so we can have a smooth transition. And for 1.11, we plan to complete the rendezvous protocols and GPU pipeline, then the active message support. And further steps are to implement all APIs, remove the current code which handles the endpoint configuration, basically clean up most of the endpoint configuration structures. And we also have a plan to support a rendezvous with IOV list. And we can use these protocols as basis for wire compatibility. For example, we could define the protocol version and only compatible protocols would be selected. And also the performance estimation model is something which you can tune over time. So today we have something which is, let's say it's good enough, but we obviously would keep on finding cases where it's not accurate. So it can be optimized independently of the protocol itself. Okay, so this is it. Any questions?
Any questions for Yossi? As I mentioned earlier, Yossi, I would like to see like measurements for the overhead, how much overheads it adds compared to selection logics that we have now, which is, one branch with pop count vs k-hash. K-hash is relatively fast, so shouldn't be huge. But I think it will be, indeed, it will be slower.
Actually, I don't have the numbers now, but I did some measurements and it's same or better, especially for rendezvous.
It better than pop count?
Yeah.
Do you know why?
So
Like one instruction there.
Yeah, so not all.
x86, right?
So the problem with pop count is when you build RPM, for example, it doesn't enable that by default because the RPM are supposed to be portable and so on. So maybe it's not a real problem, but other than the pop count, we still have quite a lot of logic in multiple places. But it's at least, even if we don't look at the rendezvous with medium-sized messages where we don't take the fast path short, it's comparable with the current performance.
It would be good if you can publish
Yeah.
full table of the numbers as you kind of submit PR.